one way to solve these things when you have values raised to exponents is that you want to get your bases to be the same. Because if you have things that have the same base, you set the exponents equal to one another. So what happens here is that as soon as you can get a common base, then you set exponents equal to each other. So that's one of the first things you look for. So if I have 4 to the 3x and 8 to the x plus 1, what do you think their common base is going to be? 2. So you want to rewrite 4 as a base 2. So you get 4 squared times 3x. Sorry. And then 8 is what as a base 2? 2 cubed. And notice, you have to make sure you throw this in parentheses. Don't forget that. Do you have the same base on both sides? Once you have the same base, the exponents drop. You can do log base 2 of both sides to show the actual step, but once you have the same bases, their exponents have to be set equal to each other. So you wind up with 6x equals 3x plus 3. X equals 3, and x equals 1.
Oh, this is just the next
So, okay. Because, what's 3 times 1? What's 2 times 3? So this would be 2 to the 6th. What's 1 plus 1? What's 3 times 2? So this would be 2 to the 6th. Are they equivalent?
Yes, they are.
Math. Okay. Not all. I mean, it's not a bad habit to get into checking stuff, because eventually we will have problems that are extraneous. It's an answer, but it's not an answer. Okay. And as you can see, it only takes a quick second to double check some solutions here. Okay. So you have 9 to the 2x equals 3 to the x minus 6. G, what's going to be your common base? 3. Would you math better? Do we have the same basis? Excellent, that's right. So you have 4x equals x minus 6. So 3x is negative 6, x is negative 2. If you substitute all that stuff through, you're going to get what? 3 to the negative 8 and 3 to the negative 8. Okay, whatever. It's the same thing on both sides, isn't it? And go to the next one.
I like that.
Okay. Sometimes you have to solve with the exponent and you don't get a common base. If you don't have a common base, this is how we solve it. You take the log of both sides. But you have to think about the property. The property of logarithm says log base b of b to the x is x. You have to use that base to be the same. So what base would I use to get the x to fall for that first one? 2. So I take the log base 2 of both sides. And now I got to show you how to type that in your calculator. These two are the same, exponent falls, and you get this answer. in your calculator, is it alpha window, I think? Is that right?
It is.
Alpha window 5, I believe. Is that right? Use alpha window 5, it'll come up with a cursor on the log base for you right off the bat. You just type in 2, arrow over to 7, and hit enter. Round to 2 decimal places, please.
One. Is it 2 decimals?
Hey.
There you go. 2.81. If you check this, you would take 2 to the 2.81. Is it close enough to 7? Yeah, close enough. So that's kind of what. There's a trick that's too far is when you should check your solutions, and you'll see what you'll pick. I don't think I need to do another one of those. Ten to the 2x minus 3 plus 4 equals 21. It's basically the exact same thing we just did, but with a couple extra steps thrown in there. So what you want to do is just work your way backwards like you would normally. What do you do first? Subtract 4.
Subtract 4, good. Subtract 4, we get 10 to the 2x minus 3 is 17. And now how do I get that 2x minus 3 to drop? Log 10. Now, do I have to do log base 10 or can I just press log?
You just press log.
I just press log. Log is, if you just press the log button, it's already standardized to base 10. So then I get 2x minus 3 is the log of 17. So what's nice is that you can put this in your calculator at this point, because I'm hoping that you guys realize that log of 17 is just some crummy number, right? Yeah. To that crummy number, you'd have to add 3. And then after you add 3, you'd have to divide by 2. So, log 17, enter, plus 3, enter, divided by 2, enter, 2.12. See what I'm saying by we'll be able to finish all this out by Friday without a hassle?
Mm-hmm.
I forgot what they call this one. All right, log equation. So you have log base 3 of 5x minus 1 equals log base 3 of x plus 7. Take a guess at what you do.
Divide by
Log you divide by log.
Nope. Nope.
You put it in your calculator and see what happens.
Can't you like,
Go for it.
you could like subtract?
Nope. They have the same base, don't they? No.
Add them.
Put it
They
there.
both- they-
You gotta move them to the same side.
Get rid of them.
So in this case here, you guys are overthinking this tremendously.
Of course. We're confused.
Log.
Are these the same base?
Oh, same base. Duh, it's right up there. It's so dumb. That's what we said.
Drop them.
Oh, don't you go,
said that.
what is
said
this?
that.
He's throwing down on me? Come on now.
You said drop
So
the
you were
log.
right.
And then
We're not dropping a log, that's what, in some other room.
Then
Oh, that was.
then you subtract x.
Sorry. It's slowly meandering about, people are getting that one, yeah.
I got it right. Equals 2.
So you're dropping a deuce?
Oh.
Comes full circle. Just, is it June?
There's no Lincoln logs in the same house.
That's what I was trying to say.
You didn't say it loud enough.
I said subtract instead, because I was assuming you just get rid of the wall.
There's no angle side in math. Don't assume.
I don't know what that means, but. No, like I don't know what it's joking. I know what English.
It's mistake.
I took that class. I
Okay. You took it, but I don't know, were you there? No.
Were you
Were you there physically? Or, I don't know. Alright, same deal here. Log base 2 of quantity x plus 2 equals log base 2 of x squared. Since you have the same log bases on both sides, another way of looking at being able to undo this, if you will, is to get rid of a log base, you would exponentiate to the same log. You agree? That would undo it. That's technically what's occurring here. Same idea is, since you have the same log base equal to the same log base, whatever it is of, those have to be equal because it's an equivalent form. So we just set them equal to each other. So you're going to get 0 is x squared minus x minus 2. What times what's negative 2? Yeah, you got to get negative 1.
freaking factor.
What?
That one factor.
Well,
Does it ever go?
Negative 2 and 1. So we have two solutions here. 2 and negative 1. So you need to check them to see if they both work. 2 plus 2 is? 4. 2 squared is? So 2 works. Good. What's negative 1 plus 2?
1.
1. What's negative 1 squared?
1.
1. They both work.
Yay.
Sometimes they might, sometimes they might not. Always double check your answers. Okay? Always double check your answers. Okay? Thing. Okay. Let's change it up a little bit. What happens when you don't have log base on both sides of the equation? You need to be able to undo a log. Gotta get some Pepto for that.
Oh. They just keep on coming. The jokes are now these
Oh, man. Hey, stop squirting over there.
What? What?
Because you would, you have to squirt.
That was me?
I don't know.
I don't know. It couldn't be.
I'm telling you. So in this case here, this is the idea where I'm going to exponentiate both sides. Because if I put this and create this to become an exponent with a base 5, since these bases are the same, this would fall.
Okay.
But I have to do the same thing to the other side. By exponentiating, it keeps everything the same. It keeps it balanced because I'm doing it to both sides. I'm just taking all that and raising it to the next one. Use the properties of log base. When I have some base raised to the log of the same base, whatever it's to falls. They undo one another. So I'm going to get 3x plus 1 is 5 squared, otherwise known as 5.
and you get 8. Okay. So check it. 3 times 8 plus 1 is 25. Log base 5 of 25, well, that's log base 5 of 5 squared would be 2. These are a lot of these things when you have integer values are really easy to check. Okay, they're very, very easy to check. Plus you got a calculator, unless I take it away from you.
Calculators are fun. They are.
It's raining.
So,
No.
so what do you think you do first? What's that?
The 2 over the x squared.
Ah, do you need to?
Should.
Well, let's see what happens. Okay, let's see what happens. Now,
I feel like you're making it
what we can say is this. And solving it that way.
That's right.
That's right.
All right. What if you did it the other way? What if you just did it? Let's see what happens.
Let's just see what happens.
What I do there?
You just subtract 13.
Right.
That's what I did,
Okay.
and I went right to.
All right. Now work both ways. See what happens here.
Subtract 15 either way.
So doing the same thing.
Okay, that's what I am doing.
That's what I got
Okay.
so far.
Excuse me. Here, what do you think you would have to do first? Divide by 2, right?
Oh.
So then I have the log base 2 of x is 8. Here, you'd have to exponentiate. Do you agree?
You're like, log base 2 is 8. You're like, you have to exponentiate. Right.
Boo.
I know.
Anyway, so I get x squared is 2 to the 16th power. I don't know what that is. Something.
Big number.
1,000.
I still, and
17.
same thing here. Same thing here. I have to exponentiate the other side, don't I?
That's close.
So I get x equals 2 to the 8th. How would you undo squaring? Square root. Square root's the same thing as what power?
2.5.
Half power.
Well, most of that goes
Exponent rules tell me that I'm going to get 2 to what power then on the 2 to the 8th.
So you're doing way more work on the other side.
On this side? Yes, sir. What you said was not wrong.
Still works.
What you said was not wrong. You get the exact same solution. And that's what's cool with sometimes if you work with properties. If you follow the rules verbatim, you will get the same answer, but you use some shortcuts.
So, the only difference on this side is that you divided by 2 over there and you put it like square.
Yeah, we went back and we used we condensed it. Instead of this is going this way is expanding, coming this way is condensing. So we condensed it and then worked out. So by condensing something, you're going to have to undo it again later. By leaving it expanded, it's a little less work. What I wanted to do, and I'm really kind of glad you said that, because usually people are like, "Oh." But the fact that being able to show you guys that it works either way is kind of nice. Okay. So it does work going either way. I recommend way on the right because it's quicker.
Does it work all the time?
Yes, sir.
All right.
Because you're treating it as a coefficient of some variable, if you will. Okay, and it works, and it works. Okay. You make it more difficult if you like.
No.
Sure. I mean, it's early, I mean, we got time.
No.
Okay?
No, we're gonna get it.
What?
When you have to worry about, bless you. Quite certain, no, not all you guys are getting played. What happens a lot of times,
1 out of 4 people get like,
80% statistics you make on the spot, they're half right.
yeah.
You didn't know that?
I do that because I do it all the time.
Not more Western, actually.
Anyway, so the problem like this, this is the setup when you have an addition problem on one side and there's no log on the other. This is where you do need to condense. What I want you guys to do is when you see something like this, think that you're going to have to condense right away. You're going to get the log of 5x times x minus 1 equals 2.
That's what we're going to go
Okay? How do I get rid of the log? You ten it. You exponentiate it.
Why didn't you say it then?
You okay with that? The reason that works with the 10 is that the common log is base 10. Okay. So from here, the stuff on the left, that junk of the logarithm fall, and you get 5x squared minus 5x equals 100. Yeah, we'll subtract the 100, set equal to 0, and divide everything by 5. Oh no, it's the first Tuesday of February, and it's 10 o'clock. Yay. So you divide everything now by 5. What times what's negative 20? You add together to get negative 1. Gives you possible solutions at 5 and negative 4. And then you go back and take a look. So you have possibles at 5 and negative 4. And you'll probably be able to tell right away which one you're going to be able to throw out. The negative. In this case here, you can't take a logarithm of the negative value. So your only answer here is going to be 5. Okay. Now, the other problem we had earlier, our negative worked because when you squared it, it became positive. When we added it to the other number, it worked out to be positive. Here, if you use the negatives, it doesn't work. Okay? So don't just think automatically that the negative value will always be the one that doesn't work. It could work, it just depends on the scenario. Does that make sense?
Yeah.
Let's see here. Sure. What I did is I kind of piecemealed things together so there weren't a lot of the natural log ones.
God, they're
I'm trying to remember if I wanted to get
Problem.
It
Yeah,
looks
pretty
like a lot
much.
of pounds, but I feel like it's not.
Yeah, no.
Yeah. Solve that.
I'm probably not gonna die.
You know what? No. We can do natural log stuff too.
What?
Don't add
No.
I didn't even think about that. We haven't done a natural log problem yet. Why am I skipping this? Well, don't write it
We don't
down.
like natural. We're the ones. Yes. We don't like natural.
What do you call it?
It's like you throw a chunk of a video.
Oh, yeah.
Hard to
That's the
say.
same question I asked you.
I don't remember.
All right, e to the negative x equals 6. I totally forgot to put a natural log or an e problem here for you. How do you undo e?
Ellen.
Inverse.
You natural log it.
It's an
It's actually ln.
It is?
Yeah, it's
That's what I am.
So did I.
Looks like I am.
It's log of the natural base.
No, it's I am. I did I am with the inverse.
It says
I always
L.
put it as a capital I.
So you
Okay,
take the
well,
natural
we can
log
find
of both sides. You get negative x equals the natural log of 6. Which means x would equal the natural log, the negative natural log of 6.
Almost
Wait,
like
what?
I am.
Yeah.
In 6.
And then how do you undo natural log?
The E in.
It's pretty easy.
God, you're killing it today.
I'm sorry, what's that? Sure.
Still don't.
Is it 100?
10.
10 natural log 100x minus 3.
Oh, I thought that was the absolute value of it.
No, 10.
10 I am.
10 natural log 100x.
Dude, it's an I.
It's an I. I thought that was absolute value.
I have a feeling that siren's broken.
Yeah, I don't think it's really on the farm.
It goes for 10 minutes.
10 minutes? Why do they need a peasant for 10 minutes?
Let's look at 5, but math is hard.
He was the one that said.
And
5 minutes.
I'm close. And
Dude, you were like 10 minutes.
100 x.
Yes, ma'am.
Is there ever like a better tornado or
You know what?
That'd be awkward.
I don't know. I'm sure there has been.
That'd be perfect.
Like what would happen?
If they're testing it, well then, obviously, what would happen is, the radios the deans and the principal and all those guys have, they've got a weather channel, like not the weather channel, but they'll have, weather alerts that'll pop through, so if there is a warning or something, it'll come through on that right away. You guys have walkie-talkie? Okay. Sorry,
We need home.
we had, okay, so,
Might as well just have a pager.
This man is.
anyway, so we have walkie-talkies, because our kids like walkie-talkies, they're kind of cool.
Walking those
You know, and when we go camping, a lot of times we're out hiking, one of us will take one kid, the other will just kind of go walk around, over, just kind of have
When
fun.
you talk to random people.
But you can do that too, but what's nice is that when you're out in the middle of nowhere and you don't have a radio reception or your phone reception and stuff like that, and you do get some gnarly weather, because it happens. Summertime, you get storms and stuff like that. And your walkie-talkies, if you have a certain type of walkie-talkie, it has a weather band radio on it, where if there's in your area where you're at, it just has a little GPS thing in it. No, it's a CB. It's weather band radio is a different frequency, and it's broadcast through like CBs and stuff like that. It will come across as a weather roller, like you've seen those radios that people have, like weather alert radios and stuff like that. It's broadcast totally different frequencies, so it picks up that frequency. So we were camping, I don't know, 3-4 years ago up in Minocqua, and we're in the woods and just no receptions or anything like that. And we knew there were some pretty good storms going on, some pretty good thunderstorms and whatnot. And our weather radio on our walkie-talkie went off saying that there was a tornado warning. So we're like, okay, let's get out of our camper and go find tornado shelter. So we had to do that. I mean, that's the reason why people still have walkie-talkies, not just because they're cool, but it's kind of a nice little safety thing to have. Anyway, what do you think your first step is? Yeah, 3. Then what do you think you do? 5 by 10. Yes. Then what do? You E it. So you get 100x equals e to the 12th. Remember, natural log is log base e. So in order to get rid of the natural logs, you would exponentiate it with e. And e's. Oh. Come on, not even smart out of that one. Thanks. And then solving for x, your last step is to do divide it out. And you go to the next problem. There's really not a lot of goofiness to this stuff. It really is pretty straightforward.
That's right.
Let's do this. So this is section 8.6, page 505. Oh, let's go 26 through.
Wait, is it those other pages and this, or just?
Dude, it's the same.
Okay. Don't forget, some might have a solution, some might not have a solution, some might have an extraneous solution, some might have all real. I don't know. No, just do those. I forgot that this year I brought back in the natural log. Those are the signs that I had last year. And I realized, let's do natural log stuff. It's more fun. Okay?